All right, number 6 is starting to look pretty hairy. Pause, try and work through this. If you get stuck, come back and watch. So I can factor the denominator. I can factor out an x squared. But that leaves me with an x squared plus 1, which I can't do any better with. So I have 2 quadratic denominators that I have to think about carefully. So I'm going to say I have a 4x cubed plus 6x squared plus x plus 2 over an x squared times x squared plus 1. And when I split that up into pieces, I have 2 different things happening. First, I have a repeated linear factor. X is linear on its own. Y equals x is linear. So I need to allow for the fact that there could have been, had to be an x squared, but could also have been a secret x sneaking around there. And then for the irreducible quadratic, you don't have to make 2 fractions for this one, but I generally do just because it saves me some trouble later and doesn't really make any difference up front here. So that's going to be my setup. And again, the x squared plus 1 you could just keep as 1 fraction with 2 terms in the top, but I'm going to split it up into 2. So with the repeated linear factor, and this is what you don't want to confuse, you only need constants for both of those. People want to put an ax plus b above the x squared, but remember that when you add the a over x squared and the b over x, you're going to get the b multiplied by x, so you're going to get that linear numerator without doing that. So break it up into the most simple pieces possible. If you can break out extra factors to make more fractions, then that lowers the degree that you need on top. For the x squared plus 1, there is no way to break that down into linear factors. So because it's second degree, it does need a first degree numerator, so it would get a cx plus d. My advice is just to immediately split that d off into a second fraction. But notice we do in fact have linear possibility with the x squared plus 1. Okay, and then clear fractions. So we're going to get this 4x cubed plus 6x squared plus x plus 2. And then we're going to have the x squared will cancel from that LCD, but the x squared plus 1 won't. And then with the b, only one of the x's cancel, and we're left with the x squared plus 1. And then with the cx and the d, for both of those, we're going to have an extra x squared. Okay, the other thing that's nice, if you split that into 2 fractions, it makes it a little less messy to multiply things out later if you want to. So looking at this, I do think that I can use my first trick. I always do that one first. It makes life really easy if it works. So I'm going to let x equals 0. That will wipe out a lot of stuff here. If x equals 0, all that's left on the left-hand side is the 2. On the right-hand side, I get a times 1 plus b times 0 plus c times 0 plus d times 0. A equals 2 is pretty much a freebie. Okay, so I'm going to write this back up at the top. For now, I have a 2 over x squared. Okay, and then I still have some blanks to fill in. Next, I don't get any other nice ones. X squared plus 1, one of the side effects of not being, or one of the ways you can see it's not factorable is that it in fact never equals 0. So you shouldn't get any factors because factors are always correlated to a 0. But what I can do is I can use my other trick where I compare all the coefficients. So here, let me write up above what I have. I have an ax squared plus a. And then I have a bx cubed plus bx, and then I have a cx cubed, and I don't need to write this one, but I will, and a dx squared. So notice, I can group together, I can say, okay, the only x cubes are the bx cubed and the cx cubed, which means that 4x cubed has to line up with that, and we don't even have to write the x cubed, we could just say, the b and the c coefficients have to add up to the 4. So there's one piece of information. So now we've got the b x cubed, the cx cubed, and the 4x cubed matched up. X squared, so this was the x cubed information. The x squared information, we have a 6x squared on the left. On the right, we have an ax squared and a dx squared. So we can say the 6 has to add up to a plus d, but I can actually do even better than that because I already know that my a is 2. So notice that one gives me d really easily. So now I know a and d. I still need b and c. Let's keep working our way through. So this was from the x squareds. From the x's, I can say I have a single lonely x on the left, 1 times x. On the right, I have the bx, and that's the only one actually. So b has to equal 1. And then we could keep going, but I don't think it tells us much. We have an a equals 2, but we already know that. The only thing we're missing right now is the c, but now that I know b, I can go back to this and say, oh, that's an equal, sorry. 4 equals 1 plus c, which means c has to be 3. So playing with those coefficients can be really handy when you have these irreducible quadratics or repeated linear factors giving you a little trouble. Okay, so b equals 1, I need a 1 over x. C equals 3, so I need a 3x over x squared plus 1. And then d equals 4. Okay, so, sneak that out, I'm going to snag my pink, I guess. Some of these pieces are easy. So this is a 2x to the negative 2. So down below, I'm going to jump all the way down here and say, okay, the antiderivative of that is going to be 2x to the negative 1 divided by negative 1. So it's negative 2 over x. All right, so 2x to the negative 1 divided by negative 1. And then the 1 over x, that's just the derivative of natural log of the absolute value of x. The 3x over x squared plus 1 is actually the trickiest. I'm going to leave it a spot. 4 over x squared plus 1, that's just an arctan. 4 times arctan x plus c. Okay, so let's do a little work for this 3x over x squared plus 1. That's a w substitution. So we get that, and I'm actually going to divide out the 2. Okay, so we can replace, sorry guys, I didn't leave myself enough room. I always harass you about showing nice, neat work, and I'm making a huge mess, so we'll continue this with some side work. We're going to get a 3, and then x dx gets replaced with dw over 2. So I'm going to say here, I'm just going to move that in front here and say this leaves me with a 3/2 dw, and then the x squared plus 1 is my w. So the 3/2 is just going to go along for the ride, so 3/2, and then the antiderivative of 1 over w is another natural log absolute value of w, but w was an x squared plus 1. So down here, we're going to need an x squared plus 1. So I think that has all the integration tricks that you'll need. You're either going to be doing power rules, you might have to do a u substitution, you might hit a natural log, you might hit an arctan. That pretty much covers what you should see in this section, I think. All right, thanks for watching.